thanks for inviting me. This is a paper I apologize some of you have seen before. If you have seen it before, one thing is different. There was a mistake in the earlier version that's now fixed. At least we hope it is. So this comes out of a project that we've been working on for a long time. Francis in the back, Sam Kortum, and myself. And Francis, as you may know, has his origins as a labor economist, and he's been very interested in the effect of the interaction between trade and employment outcomes. The earlier work with Biscoop reflected that. And we began this project some time ago, and we began it by looking at data. Francis showed us a lot of very interesting data. And part of we were slowed down because when we were looking at things, kinds of models we were used to looking at, working with, really weren't explaining what we thought was going on. Now, I think an important part of a lot of research in the last decade and a half, and we saw it in Gianmarco's presentation, is this work that's introduced a lot of producer heterogeneity into general equilibrium analysis. So the trade data was showing us all this producer heterogeneity, but we go look at the data. When we looked at the models that came out, we continued to think of demand as monolithic and technology as monolithic. And when we look at the data, we see there's just a lot of heterogeneity in input decisions and in who buys from a firm. And that's really what we're struggling to come to grips with. Now, one of these is heterogeneity in inputs. This is the labor share in French manufacturing firms. This is the distribution of the labor share going from 0 to 1. And you can see that while I had been used to working with production functions that had a common labor share, in fact, the labor shares are all over the place. There's some here at 0. I was very surprised when I saw this. So was Kortum. Francis was not surprised, and this is the second time at this conference his ex-wife's business has come up. But Francis said that my ex-wife is here because she is she's a clothing designer, but classified as a manufacturer, but with 0 employees. So that's why we have this spike here. This is just doing the same thing for the unskilled labor share and what the distribution of that is. So how do we think about this kind of heterogeneity and how firms are producing? Then another part of the project has been to look at the buyer side of things. So Francis with Julien Martin and Isabelle Méjean have been looking at data on who's buying from French exporters. The data are from the EU. Just to show some pictures there, this is not a new picture in our research. We had a picture like this in our earlier paper. Here we have market size, absorption of manufacturers. Here we have the number of French exporters. It's an upward sloping relationship, a somewhat noisy one. If we divide by French market share, we get a fairly clean upward sloping relationship. By the way, we've seen this pattern in data from other countries. The slope here tends to be not very much less than 1, but it's obviously positive. It tends to be around 0.6 to 0.65. And that, as I say, that's something we've seen in the French data. We've seen in data from Uruguay, data from Brazil. If we look at the relationship between market size, market share, and the number of firms. Now, what we hadn't been looking at before is the number of buyers a French seller has. So here's the mean number of the number of buyers per exporter, looking across a set of EU markets. Again, market size here, and we're seeing that the number of buyers is growing with market size. But notice also what's kind of even more first order is that the numbers are small. We're not seeing kind of everybody buying from this firm. We're seeing just a small set of buyers. This is just taking the same information and looking at it across different sizes of firms in terms of how many buyers they have. You can see here we're looking at, we just chose 4 markets spanning the sizes of the different countries, and you can see that for the top exporters, the number of buyers does go up quite a bit. Not quite in proportion to market size, though. Even at the 99th percentile. So yeah, so some interesting regularities here. But as I say, the models we've been used to working with have a continuum of sellers and a representative buyer. So we've been thinking about how to come to grips with this kind of these kinds of observations, but we also wanted to have a GE structure. So what I'm going to be showing you today is going to be our attempt to come up with a general equilibrium model that can incorporate, at least has the potential to incorporate some of these features. Now, the pictures I showed you at the beginning, number of exporters, market size, number of buyers, I'm going to end with pictures from our simulation. So as far as we've gotten is we have a model that we can simulate that delivers pictures like the ones we were looking at. We haven't estimated the model at this point. We've done a very crude calibration, but we're happy at least that we have a general equilibrium structure that can deliver the kinds of relationships we're seeing there. Now, just some features of the model. We're still hanging on to the continuum at the aggregate. This allows the aggregate economy to have nice, simple features. We can solve for the general equilibrium. We can solve for relative wages. Analytically, we're working on a program, and actually I have a student at Brown Laurent Swicht who is working on this problem, and she has a computer program that is doing lots of stuff numerically. She doesn't need the continuum. She's written a program for us that solves our model without the continuum. I don't have anything to show you yet from that. But so but we have the continuum with the aggregate, but the outcomes for the individual firms and for the households here are going to be granular, meaning that if a firm or a household is only going to be in contact with an integer number of sellers or buyers. They're not selling to the economy as a whole. Yeah, so.
Clarification question. So are these in the manufacturing sector, or should I be thinking of wholesalers?
These are manufacturers. Yeah, these are manufacturers. So again, as with Gianmarco, we think that oops. Okay. There's a lot of literature we relate to. I just want to mention a few papers that we're particularly close to. Ezra Oberfield's job market paper, like us, has a structure where their supply chains get created. And a firm's success partly depends on the efficiency of its suppliers, the supplier it's lucky enough to come across with. Like Stefania's paper, in her AEJ paper, we're going to allow firms to make input decisions where they may be deciding between goods and people to perform particular tasks. We're also related to the network literature. Thomas Chonet has a paper in AER, and I have some work with a bunch of co-authors on buyer-seller relationships. It's a dynamic model, but it's partial equilibrium. And the trade-off here is we're doing general equilibrium, and I'll give Andreas a plug that his paper is coming up on a related set of issues.
What about the work on sourcing? What about whatever? Isn't that related to that? So you're looking at firm sourcing?
Oh, you like the Tintel knot, Antras Tintel. Yeah, I probably should have mentioned that as well. Yeah, you'll see our structure is kind of different. For Those models, I think, are a bit more in the Mellitz 2003 tradition. You'll see we're going kind of far from that. We're taking we started quite close to that and kept moving farther away. So let me talk about the structure of this. We're going to think of a household or a firm just having a set of purposes. And we're going to label them, we're going to have capital K of those. Now, we're going to be Cobb-Douglas here. We're kind of moving backward in one sense. You'll see why Cobb-Douglas is very nice. And we've explored leaving Cobb-Douglas, and we just lose anything analytic. So we think when as we move to do things more numerical, we can be much more general, but our analytic results are going to require that these purposes, and it's like a need for a household or a task for a firm, they're going to have these Cobb-Douglas shears. Now the thing about these purposes is that they can be fulfilled either by labor or by a good. And we'll think of it as a good produced by another firm. So for a firm, the production of firm J is going to depend on the firm's efficiency. Well, this is going to be a one-product firm. And the firm has some efficiency. This is like in the Mellitz model. But then it has a set of inputs, and there's a Cobb-Douglas aggregator. It's using input in some amount. These are just constants, the shares there. So M here is the input, but we haven't said yet what that is. Now, for each task, there's a type of labor. We're going to have different types of labor. This is you'll see one of the things we'll be getting out of this is statements about income distribution if we have with different types of labor. And this is getting at the idea that changes in trade barriers may have effects on relative wages for reasons that are somewhat different from in the standard literature. So we could think of the cost of labor. So every task has a type of labor that's appropriate for that. So if you use labor, you pay that labor wage. We call WKI the wage you have to pay if you decide to have labor doing your task. Each firm is going to have some productivity of labor doing that task. And we're going to make an extreme assumption that makes our life very easy. We have buyers and sellers are bilateral monopolists. We're going to give all the bargaining power to the buyer. What does this mean? It means that the seller is going to sell at unit cost. So our model is going to have no profits. What's the cost? We can't have fixed costs. Now, we thought that was a terrible cost when we first looked at this case and saw this as the easiest one to work with. And then we thought some more and said, no, really, a lot of the pictures I was showing you in this framework can be delivered without fixed costs. And you'll see there's not much decision making that's going to be made here. So we work with alternatives, Bertrand pricing, where there are profits, and maybe rent sharing with workers, where we could have fixed costs. They're messier. Francis and Sam at one point worked out a lot of results with Bertrand pricing, but they're very messy, and I didn't want to look at them, so I went back to doing. Yes, I didn't look at them. Yeah.
What is the difference between that and simply saying that there is a monopsonist?
No, everything here is competitive. There's no monopsonist.
No, but is this bilateral? I mean, you have bilateral monopoly. You give all the power to
the buyer.
So it is a monopsony.
It is, but it's a monopsony that itself has no bargaining power with its buyers.
Okay. So on the other.
So there are no profits.
So when is a buyer is not going. When is a buyer is power. When is a seller is. Okay.
Yeah. So everything is pushed down to marginal cost pricing here. Everything's unit cost pricing. So what's the unit cost of performing task K? Well, it's going to be the labor cost, which is the wage. If you hire workers for a firm, this is the wage you pay. This is the productivity for you, your firm J, of workers performing this task. But then you might find a seller of a good that's appropriate for that task. And what you'll pay is that seller's unit cost. Okay? And that then is your unit cost of performing this task. And then what's your unit cost as firm J? Well, it's just the Cobb-Douglas cost function for these costs. And this is if you're selling in destination N, we have iceberg costs here. Here's your overall efficiency. So your unit cost here depends on your overall efficiency. And then the costs of the inputs that you happen to be using. So to get anywhere, we're going to need to make some assumptions about distributions. We're going to make a standard one for the overall firm efficiency, that it's a Pareto, a firm's efficiency is drawn from a Pareto distribution. So the measure of potential producers with efficiency greater than Z is TI, Z to the minus theta. So TI is kind of reflects the country's the country's endowment of technology. Also, these Qs, if you use labor to do a task, the Q is drawn from a Fouché distribution with no parameters. And another result that I'm going to posit now, these are primitive assumptions. What we're going to posit is the measure of suppliers in market I with unit cost below C is equal to some magnitude upsilon C to the theta. Now, unlike these assumptions, which are assumptions, this is something that's going to emerge as an equilibrium outcome, and we're going to get an expression that tells us what this upsilon I is going to be. So those are our assumptions about the technology. Now we're going to have matching. Okay, there's going to be buyers and sellers don't meet on Walrasian markets. They match with each other. So the key parameter here is going to be this thing we call lambda. So we let that vary by market, and we let it vary by the purpose K. And we also say that, well, maybe there's some congestion. So this is like the probability that a buyer and seller are going to meet. And we're going to introduce some congestion, which is often done in matching functions, that if you're a high-cost seller, lower-cost sellers make it harder for you to meet buyers. That as there's actually going to be no upper bound on costs, and it's going to be useful, and especially in matching data, for it to be harder for high-cost firms to meet buyers. But the key parameter here, and it's kind of the key new parameter when we go look at the general equilibrium, the thing that's going to be new is this lambda. And what lambda is, it's a parameter. It's indicating how easy is it for buyers and sellers to meet. And we're going to have that vary by task and potentially vary by the market. We could also have it vary by country pairs in kind of an iceberg way. We haven't done that yet, but it would simply be a richer parameterization than we currently have, and of course give a different reason for trade barriers, not physical costs of trading, but difficulty in encountering, and they're distinct here in this framework.
What do you have in mind for this lambda being heterogeneous? Because you're putting a lot of stuff on this matching. You were very unsurprising for given your work with the labor economy. They're very simple, no market power in the labor market, but here in the matching.
Francis is very unhappy about
so
that.
What's so specific about in one sector it's easy to meet? What's the story behind? What do you have in mind? Why do you want to match? Focus on the matching so much.
Yeah, so maybe this is a story about, I kind of think of standardization, that you're a firm, you have a particular task that you need done. Maybe it used to be you had to have your own labor do that. You didn't encounter sellers who were selling an appropriate good for this task. But then maybe somebody figured out that this task could be done by a particular machine that somebody had developed that could do lots of different tasks for different firms or households. And that consequently it was much easier to encounter a supplier for that particular task for you. So that would be one example, kind of standardization. It could also literally be a search story. And now remember, this isn't search between workers and firms, this is search between firms and firms. This is like Walmart trying to find somebody in Mexico to make sweaters or something. Think of it as that. And we have this gamma here that is sort of how hard it is. Gamma could be 0. That's going to flatten the size distribution of firms. That's why we introduced it. The parameters here, there was a bit to keep track of. Theta was our basic parameter of the Pareto distribution. Phi was that draw you got for labor productivity. And gamma is this, how much congestion is there among suppliers. And to get analytic solutions, we're going to have to impose that relationship between these 3 parameters.
Jonathan,
Yeah.
when you do the numerical analysis, you're going to keep this?
So far we have.
But it's not needed, right, when you go to numerical?
That's a good question. The program we've only sort of started working with, so I don't know how brave. Right now we're being extremely cautious with it. Mainly trying to make sure it gives us results that we know are true analytically, so we know that it's right. And it's been doing that. So we haven't been very brave yet. So yeah, there's a lot of stuff here I'm hoping we can relax when we get numerical, but we're still kind of clutching to our analytic solutions at this stage. My graduate student wrote this program. It seems correct, but we haven't quite, we haven't pushed it very far. It's also kind of slow. So with this intensity of matching, we can ask the question, you're a buyer, and what's the how many sellers are you going to encounter for your task, who's selling you something that can do your task? How many are you going to find who can do your task? Well, these assumptions about the intensity of the match mean that the number of buyers you're going to find who can deliver a unit cost below C is just going to be the integral from 0 to C of this thing across this measure of suppliers. And we can solve for that thing. And the number is going to be the realization of a Poisson random variable with this parameter. Okay. So this is going to be the number, you're going to get a random number of suppliers who can deliver a unit cost less than C, and it's going to be the realization of a Poisson random variable with that parameter. And you can see the bigger lambda, of course, the more you're going to get. The bigger the Poisson parameter is. So then what do these assumptions let us do? Well, they let us get a closed form solution for the distribution of the lowest cost. So how do we do that? Well, what's the probability nobody provides you an input at unit cost below C? Well, that's the probability that your Poisson realization is a 0, which is just that. What's the probability that the workers can't perform it at unit cost below CK? Well, that's the probability that there's no Z high enough to be bigger than W over C of K. So the probability of nobody being able to deliver at unit cost less than C is just the product of these 2 terms. And so this is the probability of no source, and then the probability of somebody providing you is 1 minus that. So this is giving us a functional form for the distribution of the lowest cost of performing that task. It's going to be, it's a Weibull distribution, and it has these parameters. The xi is sort of kind of summarizing this is sort of the high xi means it's cheaper either because the wage cost is low or because this thing we call nu ki, well, that has the lambda in it, this theta, and this psi, this upsilon. Okay, so that kind of a bigger xi means things are cheaper on average. Now, one of the things that is who's going to be doing this task, it'll be workers' contribution to that xi term. That's the probability that workers will do it, and then you'll use intermediates with 1 minus that probability. So you can see for each task, it's going to be random whether it's performed with workers or with goods, and we can then solve for what the individual labor share is just summing across tasks, and we have different types of labor, so what type of labor will be performing that task. We can then look at the overall labor share here.
Excuse me, John.
Yeah.
I may have missed this, but are there matching frictions with the workers as well?
No, we're just assuming that there's a Walrasian market for workers. You can go out and call up workers and they come. We've thought, we're thinking about doing it, we just haven't done it. Yeah, so there's been some work on what's been happening to the labor share. Now, one of the things about this result, maybe it'll be more transparent, is let's say I do an exercise where I change trade barriers. Maybe I lower trade barriers. Well, that's going to have the effect of increasing this upsilon. This is just changing not the lambdas, but just the old-fashioned iceberg. So it's going to raise upsilon. It's going to make goods cheaper relative to labor. It's going to make it the case that, and I'll show you some simulations of this, that I'm more likely to use goods rather than labor. And there has been this observation, at some point we put together this table of what the labor share is in gross production in a bunch of countries, and there has been this tendency for it to drift down, with exceptions such as Japan. This is roughly over a period when trade grew quite a bit relative to other magnitudes. I'm not going to do anything more with this. It's just saying it's suggestive of our model is suggestive of a reason why there could be some connection between lower trade barriers, globalization, and a decline in the overall labor share in gross production. We can get then, just to kind of finish up our work, we can use this distribution to get the distribution of costs. If you're in country N, what's the distribution of costs you see from firms from country I? We call that mu ni of C. We do this integration and we get a little expression here. It has that xi term in it. What's your overall costs? Those are just some things we have to define. Your overall distribution of costs just sums the measure of suppliers, sums the measure from each source. You're here in market N. And we're just going to, we get a form then. We have this thing we're going to call upsilon n C of theta. Remember, we posited that this thing had this form at the beginning. And now you can see we have an expression for upsilon n in terms of stuff. Well, this psi thing, though, is kind of a nasty object. So these upsilons then are going to be the solution to a system of equations here. We can get closed forms in some symmetric cases and so forth. But in general, we only can solve this numerically, but it's simple to solve. The paper, at some point, Kortum worked out sufficient conditions for a solution of upsilon. And it has some, these things are homogeneous in the t's and the lambdas. Kind of the economics there is that there's kind of a lack of identification between the level of technology and the lambdas. So technology is only good if you can access it. So there's this lack of identification of how much technology there is and how much you can access that technology. So there's one degree of non-identification, which is intuitive. We can't say how much is technology versus being able to access technology. We get trade shares that look kind of like out of other models. The thing is, in the kind of models Kortum and I work with, these were W's or maybe W's and P's. Now they're these whole size. So one of the things that's getting in there is how not just labor costs, but how easy is it to access inputs. That's going to be part of a competitiveness. If a particular country has a high lambda, it's going to be more competitive. It means that its firms can access suppliers better. And that's the source of their competitiveness. It turns out this delivers an aggregate production. Yeah.
Just to understand, in your original paper in 2002, you had intermediates.
Yeah. Yeah, we did, but in a very standard way. We just said, okay, there's a labor share, there's an intermediate share, Cobb-Douglas, the labor share is beta, the intermediate share is 1 minus beta, that's a parameter. Any firm that you looked at in our model would have a labor share beta, an intermediate share 1 minus beta. That's the difference.
And in the aggregate, is this going to make a difference when you aggregate?
No, well, it's going to be CES rather than Cobb-Douglas. And the elasticity of substitution is going to be bigger than 1. You may not like that. I'm not sure. I don't like it very much. But that's how it is.
And just the last thing. And so how do you identify this model with respect to the original one in the aggregate?
How? Well, I showed you a bunch of stuff. And in fact, we're trying to make it not different. We thought that paper did really well with the moments we were looking at. So we didn't want to give up stuff. We worked with other models, but we thought that takes care of these issues, but then it totally gives up on different sets of issues. So yeah, so if you think aspects of this look like our previous paper, yeah, that's intentional. We wanted it to look like that. But it was really introducing the features I was showing you at the beginning. That was we wanted to be able to come to grips with those without sacrificing what was going on the exporter side. And you'll see what we kind of do similarly on the exporter side. And then consumer is just analogous. They have these needs, and sometimes they hire labor to do them, sometimes they buy goods. Yeah?
You may have said this, is there a relationship then between the firm's productivity and the firm's labor share on average?
Oh, that's a good question. Right now, I can't say why there's a presumption, because it could be that the firm's labor share is high, in a given realization, because it had a really high Q. That is, labor productivity doing some task was really high. So they were very lucky. Labor was very productive doing this task. That made them very low cost and successful. So, but then it could have been the other way around. So there might be a correlation, but I don't know right now. Because it could have gone the other way. The firm was really lucky and met this low cost supplier. Yeah, so what we can do now is kind of integrate, and everything, I'm going to go through these slides very quickly because they're just very standard. Once we go to the aggregate, we can sort of look at labor market, our consumption, final spending is just labor income because there are no profits. Here are all our types of labor doing the different tasks. And we can just sort of look at gross production then is final sales when it's done not by labor, intermediate sales when it's done not by labor. In the aggregate, here's the labor share in households for firms. These are going to be, because of our continuum, these are going to be fairly simple objects, we can do the kind of standard Leontief algebra, which is what all this is. And here are trade shares, and we can solve for income in terms of final sales, and then solve for the labor market equilibrium. So each country, for each type of labor, has a labor market equilibrium that we can solve for in a very standard way. So one of the first exercise I'm going to show is results where, well, we did a bunch of simulations. Now the simulations here are just aggregate simulations. We're just playing with the aggregate model. We're not looking at individual firm outcomes. What's kind of funny about this model is that the aggregate, because of our continuum assumption, the aggregate is very simple to work with. Okay, if we're not interested, the complexity comes, and the reason we're writing these, having graduate students write these complex programs is what happens at the level of the individual firms is random, and we got a certain distance in closed forms. I actually took most of those results out of my slides because they're nasty. You've seen enough nasty-looking stuff that I decided to take most of that out. But the aggregates are quite. Here we have a theta of 2, a phi of 2. That the phi is that thing from the efficiency. That's wrong. Yeah, that's the labor efficiency. Here's labor T over L. This is a world labor force of 1. The way this is set up, this is pretty simple. There are 2 types of workers. They're called non-production and production. There are a bunch of countries. I don't like this when people were bringing up issues with co-authors. I didn't make these. I didn't do this. And the table we had on the previous version, but we changed some things, and then Kortum made this very elaborate 5-country thing that I get confused by. There are service tasks, there are 4 service tasks. They have a total share of 0.4, so each one is the share of 0.1. There are 12 production tasks, overall 0.6, so there's one, each one of them has like a 0.05. Now the key thing here are these lambdas. So there are these 2 types of tasks, what I call the service tasks and what I call the production tasks. And here you see the lambda for the service tasks is 0. That means that the firms can't use goods to do those tasks. They can only use workers. On the other hand, the production tasks have a lambda of 0.2. So with that, that means that, yeah, with some, there could be goods coming along. And here are some results of that simulation. The Kortum, I think, was trying to replicate going from Luxembourg, what was Estonia to Germany or something, and he created these sets of countries with these different labor shares. Now this is emphasizing very much the size effect implications of this model. And like other models, it's better to be in a big country, other things equal. Remember, the T over L is the same because of the iceberg costs. Okay, so now when I said it was good to be in a big country, that was true if you were a service worker. It's actually not true if you're a production worker. Why is that? Because in the big country, goods are cheaper. And to compete with goods, even though the lambdas are the same everywhere, in the big country, to compete with goods, your relative wage has to be lower, and here it even makes your real wage lower. Welfare is higher in the bigger country, but there's this income distribution effect. Now the key differences here of the types of labor is how substitutable they are with goods. The service workers can't be substituted for with goods. The production workers can. And here Kortum has put together looking at a small versus a large country. And one of the things you can see here is that the production workers, again, except when we go to 0 trade costs, here we're varying the trade costs, and you can see actually as we lower trade costs, the real wage of the production workers goes down. That's actually true in both the little and the big countries. And this is the effect I said, that the lower trade costs mean goods are easier to substitute for labor. Now, if we only had one type of labor, this effect wouldn't happen. The fact that goods are getting cheaper would always dominate the fact that the labor share was falling. The labor share would still fall, but so what? If there's only one type of worker, that's a good thing for the labor share to fall. But if it's your labor share and not the other labor share, that can be bad. And here we've done one where it is bad, but you can see, of course, overall welfare is going up as we lower trade barriers. Yeah.
Why are workers mobile across service and production?
Oh no, they're just not. We're just treating them as different types of workers.
Okay.
In order to illustrate this, think of them as skilled and unskilled or something. To illustrate this income distribution effect.
So you're not assuming anything about how these goods are produced? Are they that compete that compete with labor for being used in production? These goods are what? They are. I mean, naturally we think about capital goods. No?
Well, here we're just thinking this is like a Mellett's model. Every firm is a bit different. Now, in this model, and so we could give a name to what it's making. Now, in this model, we could think of the firms as the output of the firms as being heterogeneous, not only across producers, but across buyers. That's kind of getting at the lambda thing, that we could think of this lambda, we could think of it being a lot of we could think of, in fact, all buyers being idiosyncratic. Every buyer in the end, whether it's a household or a firm, is going to be buying with probability 1 from a different set of suppliers. It could be, we could think of that matching as really the buyer finding the seller's good appropriate or not for that buyer. So that's a sense in which the differentiation here could be thought of in different ways. Where a low lambda could also be, a very fussy person could be also a low lambda person, somebody who just doesn't find things that are appropriate for the particular task she wants done, or purpose she wants done. Yeah, so we're kind of formless here in how we're thinking about these. So we can, even at the aggregate, we can say some things about what's going to be happening at the firm level on kind of averages. What's the measure of firms producing in a country of different size, the measure of firms selling. This is kind of the size distribution of firms, I think, producing. I was looking at this last night. I wrote to Kortum and said, what did you mean here in terms of sellers versus producers? He didn't answer my email. So if you ask me, I'm going to tell you I don't know. And you can see in this tiny country, in fact, most of the firms don't sell domestically. This is with a trade cost of 1.2. And this is just looking at what happens as we vary trade costs in this little country and this big country. Now, one of the things here, as you can see, here we have selling firms and producing firms in a country as we vary the labor, as we vary the trade costs. Yeah. Yeah.
The customers are firms and consumers.
Right.
Do you have any result on how many firms, how many consumers?
Yeah, so here, I didn't want to spend long on this slide in case people started asking me questions about it. But we do here have the number of producing firms per worker. Notice it's smaller in the small country, and it's this non-monotonicity I'm not quite understanding. Here, it's kind of It seems to be kind of U-shaped here in the trade cost. And that seems, and I don't have an explanation for that. No, we're still, we're still pondering these. So there are a bunch of questions here we're looking for answers to.
Jonathan, there's the number of customers. The bottom of the graph gives the distribution of customers.
Yeah, and you can see the bigger firms are bigger in the big country.
But you don't know whether these are these consumers or firms?
No, we're
Together.
This is the size distribution of firms. Yeah.
firms.
Customers are only firms.
Here, well, that's what.
They're both. They're both.
Because in the model, you have also consumers that are buying there. Okay, but
Yeah, and here you have the mean customers per firm. Here. Yeah, okay. And it's kind of small. It's small in the data. But you can see we can get fairly large firms as well. So one of the things that this is where it starts getting a little harder. I don't want. What time do we end? 10 minutes. Okay. Thank you. Okay. I think I'm doing fine. Now, those are things we can get out of the aggregate model, just from the kind of relationships we have. Now, there's some things here that that require a bit more work. How many firms are there actually going to be? Well, how many final buyers are there going to be? Well, if you're a seller in a market, your unit cost is C, you're going to encounter, here are your final buyers, these are the ones you're going to encounter. Okay, so this is the number of encounters you get with your unit cost C. Now, encountering a buyer isn't the same as selling to a buyer, because that buyer might have options and they might be better than you. And you're going to make a sale to a buyer only if you're the lowest cost. And the probability that you're the lowest cost is this thing. So the number of final sales you get is just then going to be a Poisson, the realization of a Poisson random variable that's looking across the tasks or the needs for these final buyers. Here's the number of them, here's that hazard of meeting them. Here's the penalty you get, and that should be mu of C to the minus gamma. This is from the old version that was not right. And here is the probability of making a sale. Okay, that's a typo. That should be mu of C to the minus gamma.
So John,
Yeah.
the final sale is what? Is a transaction or is a customer?
That's when you make a sale to a household.
Okay,
You've met a household.
so it's a transaction.
It's a transaction, yeah. So you have to have met the household, and then the household has to have decided you're the best deal for it. Intermediate sales, now that was easier because the ln here is something we know. That we treat that as exogenous, in a standard Ricardian model. Now intermediate sales, you're only going to sell to an entity that's producing. So we're going to call the measure of producers MN, but that's actually going to be an endogenous object because it's going to depend, if there's a potential firm out there that makes no sales, and many of our potential firms are not going to make sales, they're going to have either meet nobody or meet people but not make the sale. So you're only going to be active in buying inputs if you're making a sale. So we're going to introduce the measure of active producers in a market. You're making a sale, again, with this probability, so that the number of intermediate sales you make is going to be the realization of this Poisson random variable. Your total sales then, the total number of buyers you're going to get, is just going to be the sum of these, is going to be Poisson realization across final and intermediate sales, and the number of sales in total you make is going to be Poisson, realization of a Poisson with that parameter. So that's in a particular market. You then sum across all the markets where you could sell, and that last Poisson parameter is the probability of making a sale anywhere. Then what's the measure of sellers? Well, it's going to be the measure of potential sellers who don't sell zero. This is the probability of selling zero. So this is the probability of not selling zero or being in business. So our MI is going to solve for a fixed point here again. So we don't have a closed form solution for that. We can look at the measure of firms selling in a market, which is different from the measure of firms producing in a market. Here we've simulated, and this is where I said I'd end, we've gone to this program now and simulated some firm level outcomes. Here we have market size, and here we have the number of suppliers adjusted for market share. And you can see we get an upward sloping relationship. The slope is positive, it's about 0.5. It's not quite what we saw in the data before. We don't know exactly yet what parameters to tweak, but you can see the number of buyers isn't increasing proportionately with market size. Which is what we see in the data. The number of buyers didn't increase with market size. And here in this model, it doesn't increase in proportion to market size, but in proportion substantially less. I forgot to mention that elasticity in the data. It's about 0.2. This is buyers per supplier, looking at different market sizes. And again, we get an upward sloping relationship. It's somewhat awkwardly not quite as linear as it is in the data. We're not quite sure why yet. The slope again is less than 1. I'm sorry, the previous one was about 0.5, like in the data. This one is a lot flatter, in that it was in the data as well. But it's certainly a lot less than 1. So the model does deliver at least those implications. Now, going back to this one, I should just mention, in our earlier paper, we used basically the Melitz model, and we were able to fit this line, but we fit it by letting the fixed cost of entry vary market to market. So we actually fit it perfectly. Now, what happened to get this relationship is the fixed cost was increasing with market size, but not in proportion. So we basically were kind of left with this mystery about the fixed cost of entry and market size, and why it had to increase, but not in proportion. If it increased in proportion, then there would be no effective market size on sellers. If it didn't increase at all, the slope would be 1. It had to be somewhere in between. Here, this kind of naturally, the search and matching model kind of naturally gives us this non-unitary elasticity. Larger markets, you don't sell proportionally, you don't have proportionally more sellers in a large market. Similarly here, we get this, the matching assumptions we've made, which are very simple ones, kind of automatically give us this non-unitary elasticity, these non-unitary elasticities. So just to kind of summarize then, we have a continuum at the aggregate, but what's going on at the firm level, and we're working more on this, is going to be totally heterogeneous. Every agent in the economy is going to look different here. So firm heterogeneity, there are lots of reasons for heterogeneity here in firms. We have the Melitz underlying efficiency difference, but then they're also going to be different in terms of the suppliers they connect with. So a firm might be low cost because it got low cost suppliers. They're also going to be heterogeneous in terms of how many buyers they hook up with, and then in how big those buyers are. So they're both kind of demand and supply sides for reasons for heterogeneity here. And the realizations are going to be different market by market. In our earlier paper, we had to have market-specific tastes and entry costs, shocks. to get the heterogeneity across countries and outcomes. Here, this randomness and matching kind of generates that randomness automatically. And then this is just pointing out this lack of, that we are kind of picking up this lack of unitary elasticity in things. Our earlier paper, a long time ago, Kortum and I had a paper with Bernard and Jensen where in fact larger markets wouldn't attract more sellers. Mellets has a unitary elasticity unless we play with the fixed cost of entry in a particular way. Okay, I'm actually stayed at time. Yeah.
Do you get a prediction on the ranking of buyers? There are some bigger buyers and smaller buyers. Is there anything there?
I think that's a bad question because that's where we're not, bad for me, that's where we're kind of weak. We don't get a lot of heterogeneity, because it's kind of tied, our Cobb-Douglas assumption, the set of tasks, has kind of very much bound what we're doing there. So we can play with that to get, we're not going to generate the kind of heterogeneity you see across particular firms in terms of how many suppliers they have. We're going to get some, but it's not going to give us the range. Now we can build more in by having more types of firms with more tasks and so forth, but it would be kind of a built-in thing rather than something that would just follow from the assumptions we made so far. We've been thinking a lot about exactly that, but haven't implemented anything yet.
The idea that firms have more tasks, some firms have more tasks than others, is not totally strange, right? It could be because they have more products, it could be because they have...
Yeah, it's just we haven't built those features in. Yeah, no, it's totally plausible, and it's a plausible thing that we're currently not dealing with.